Hello all. Today we'll talk about writing functions in R. So when you say function, there are two types of functions. One is the inbuilt, which is already there in R software, and other is the user defined. Okay. So there are some examples like if I say, suppose define some vector x equals to 1 to 5, then if I define mean of x, then you have some output, that is the average value of this x vector. So basically, this is the function and this is the input and this is the output. Okay, so function is a piece of code which is written once and that can be used in the main program, that can be called in the main program. So you don't have to write the function, so you don't have to write the piece of code which is already written in the function many times in the main code. So you write the function only once and then call many times in maybe in one program, or you can use it in several programs. Okay. Similarly, if you write something like mean of x, that will give you some number, that is 1, which is the minimum value of this x vector. Similarly, max of x. So these are all functions in R. These are the all inbuilt functions. Okay. Now we can write function in our own purpose. So these are some standard variables that is already written. But if I find something which is not there in the MATLAB library, sorry, not in MATLAB, in the R library, then we can define it. Okay, that is the user defined functions. Okay, so how to do that? So this is the syntax of writing a function. First, function name. Okay, I write the function name equals to function, then argument 1, argument 2, or whatever, how many arguments you have. Okay, so this is the standard thing. This indicates that this is a function. So you are defining a function, and this should be the function name. Okay, and these are the input parameters. And finally, these are some of the expressions. Some expression means these are some executions you are doing here within this function, and finally you are returning something. Okay, so this value is something which is obtained by this expression, and finally you are returning this value. So that is the output of the function. Okay, fine. So a note here that arguments, it is possible that you can define some function which does not have any argument. Okay, so function without any argument, or it is also possible that you write a function which does not return anything. Okay, we'll see those things in the following examples. Okay, let us take the first example. Okay, so the first one is the conversion from Fahrenheit to Celsius. Okay, now first I'll define the function. This is the function name, Fahrenheit to Celsius. Then this is the standard thing that determines that this is a function. Then this is the input argument, that is the temperature in Fahrenheit. Okay, so when we do this conversion, that means what? Fahrenheit to Celsius. So input is Fahrenheit, some value in Fahrenheit, then the output should be some value in Celsius scale. So that is my input, and this is the expression. Okay, so you know that conversion rule, f minus 32 by, so c by 5 equals to f minus 32 by 9. So using that conversion rule, you can find out this expression, and by this expression, when you execute that, then you will get the value of this variable, and this is what you are going to return. So output of this function is this temperature in Celsius scale. Fine. Now here note one thing. This function is a single expression function. So we have only one expression here. There is no multiple expression. In that situation, this return is not essential. So here return is optional. A single expression function by default return the value of the expression. So I'll go I go into that later. Let us take this example. How to, so here I have defined the function. Fine. Now how to call that? So here I will call it. First run it. Okay. Then this is my function and I gave the input 98.3. Okay. So 98.3 Fahrenheit and I print here the output. Okay. Let me run this. This and then okay. So this is what your answer is. So this is the input and this is the function and this is the output and then print it. Okay. Now see what I said here, the return is not essential. So let me comment this. So technically there is no return command in this function. Let me run this again. Okay. Then see that it's there. So whenever you have some function which has only one expression, in that situation this return is optional, but for good practice it's better to write that. That is a consistent rule. Okay. Now so this is the output. Fine. I can write this output in a little bit more sophisticated way. See that temperature in Celsius is 36.83. So basically you have seen this command, the paste, that paste two strings side by side. So this is what the message I have. The temperature in Celsius is, and that is the value. So basically this is a numeric value. So that's why I have to convert that the character. So this h dot character that converts this temperature in centigrade as a character. Okay, take a look. See the difference here, 36.83333, but here 36.83, only 2.2 digits after the decimal. Why this is like that? Because I have do the round off the value of temperature in C up to 2 decimal places. Okay, so that's why you got 36.83. Fine. Okay, then let us take some other example. So what I said, when there is some single expression function, that is then return is optional. But here we will see some multi-expression function which does not have any return. Suppose here we define a new function that is show stat. So I have some data, basically that is a vector, and I want to find some statistics on this data. Okay, so for that I define this function so stat, so underscore stat. Fine. So this is the function name. So this is the standard notation function, and this is the input. And this function is only one input, one argument or one input. Right? Then I defined these four variables. This is the mean value, that's the mean of this data. Max value, that's the max of this data. Then the mean underscore value, that is the mean value the average value of input data, and this is the STD value, that is the standard deviation. So here this SD is the command or the function to find out the standard deviation of this data. Now see, mean, max, is mean, SD, these all are functions, but they are inbuilt functions, which is already there in our software. Now, when I get all these values, then I will print them. Okay, so print the minimum value, something this, maximum value, then mean value, standard deviation. Okay, but here I'm just printing them, but I'm not returning any value. Okay, so let me run this. Let me run this. Okay, so first run the function, then call it. Here the vector is 1 to 6, so that is the input. Then run this one. See, the minimum value is 1. So that is true, because 1 to 6 is what? So 1, 2, 3, 4, 5, 6. So the minimum value is 1, maximum value is 6, mean value is 3.5, the standard deviation is this one. Okay, so basically the same strategy, the paste command. And if you want to ignore some digits here, then you have to do the round off. Okay, so what I can do, if I do round comma 2, that means I am doing round off on this. Okay, then I have to run the function again, then call it. Fine. Okay, so here my task was, you have the data and you display some statistics. Here I don't want anything to save or anywhere to save those values. Okay, I don't want to assign these values to any vectors or not vectors, to any variable. So that's why I don't want to return anything. So this function is not returning anything, rather it is printing something which you want. Fine. Then take another example. Function without input argument. Okay, so that at the very beginning I said the arguments are not necessary. So in some situations where you will see there is no argument, like I define one function, that is watch. Okay, basically when we see our watch, we see the time, as well as some watch has the facility date, time, and what is the day. Okay, so here our target is to display the time now. Okay, so these are some specific command you have not you have never used that, but these are some R command, and if you don't know this, that is also fine. So this example is just to show that this is possible. This without argument function is possible. Okay, so first run this. When you have done this, then let me call it. So how to call that function? So as is it does not have any input, so here this part will be empty. So watch, first parenthesis open and close, so there is nothing inside it. Now it's the time 8:25. See, Wednesday, April 22, 2020. Then time is 20 hours, that is 8:25:54 p.m. Okay, so this is in 24-hour format, so that's why there is no PM or AM. So actually sys.time that gives you, if I write this separately, see what you will get. This is the system time. Okay, this is 2020 04 22. So 22nd April 2020. This is the time, and this is IST, India Standard Time. Okay, but I can write this, but here you see this April is not here. This is all digits, and this is also not here. So for that, I use this format. First, I define this time now, which is nothing but this one, and then I use this format to get this one. Okay. Okay, actually first I have to write this. I can do this outside of this function, time now. Okay, so if you don't want to use the function, then you have to do these two things. Okay, but if I have this function already doing this task, fine. Now run it again. See, this time it's not showing any time, rather it is showing the function. What is the mistake I have done? I missed this. However, you don't have any argument, but you still need to write this parenthesis. Okay, yes, now here it is. If I do this again, see, 15 second, now it is 20 second, again 24, like that. So it is always it will always give you the time whenever you are hitting the enter key. Okay, fine. Then so here we see that we can write some function which does not have any input, but it can give you some output or some display. In fact, it does not have any output also, it just displays something. But if you want, you can display something, you can return something, just like time now. You can return it, no problem. Now take another example, example 4. You know how to do plots. So here I want to give two vectors, that is, one is x and another is y, and I want to get a 4-panel figure which will have 4 types of plots. Okay, so for that I defined the function plot underscore sub. And what is my input? The inputs are x and y. Then when you do subplots, then we have to define this command first, spar mfrow c2, 2. That actually defines the subplot. Okay, then when you define that, then this is the panel 1, this is for panel 2, this is for panel 3, panel 4. Okay, this is the scatter plot, this is line plot, this is staircase plot, and this is the vertical lines. Okay, let me run this. First run the function, then call the function here. So that is the code. X is this one, 0 to 5 with 0.5 interval, then y is the e to the power x, then plot x and y. See that? So this function will always give you this type of 2 by 2 subplots. Okay, and in all these subplots x and y are same, just the only difference is the type of the plot. So if I change the x and y, suppose if I define not xp, so suppose I define to start x, okay, then minus 5. So that is my x and that is y. Then run this. See, here I am running this. So I changed something here, and again I called this function, but I ran this command, but I am not running this one. This I ran only once. So when that is run only once, that means in the R memory it is already there, and you don't have to write this code here, and you don't have to run it here. So what I am doing, I'm just giving the input and I am running the function. This is the calling, basically this is calling the function, and when I do that, this actually running this function again. Okay, similarly if I write suppose 0, 5 star pi, comma, then so pi, comma, this is suppose pi divided by 8, and I write this as sine of x. Yes, this is what you have, the sine curve. Okay, fine. So here what we discussed today, the syntax of writing a function. Then we consider 4 examples. The first example, you have the input and you have output, and in fact this output, the return is optional. And then we took another example, that is basically you have some input data, but there is no return. So it is a multi-expression function. So technically if you don't write return, then it will not return anything. And then, and in fact we are intentionally we are not returning anything because we don't need. Then I consider another example where there is no input. Okay, then we consider another function where we have inputs and we are not returning anything, rather we are doing some plot. And in fact if you want, you can add 2 extra command to save this figure into some PNG or PDF or whatever. So open the file first and then do the plots and then close the file. Okay, good. Then call the, okay, that is done. So this example is done. Now here so here we'll do another example. We'll take another example. Because in all these functions, one thing you can notice that either they are not returning anything or they are returning only one value. Okay, so if we consider some function which returns more than one value, how to do that? A very simple way. Let us take an example like example 5, function returning multiple outputs. Okay, suppose I'll write here mean and st. What? std function input data. So basically we are providing some vector here, and then mean val equals to mean of data. Then std val equals to st input data. Then I'll return fine. So basically I'm returning this is a vector. Okay. Okay, let me call this. Suppose define some vector x equals to 1 2 5, then print std of x. First run this, then x, see that? So this is your mean value and this is your standard deviation. Okay, so you can have multiple outputs also. Okay, now it's your job. So I have done 5 examples. Now it's your turn. Here are 3 problems you can try. Okay, first one, conversion from Celsius to Fahrenheit. That is very easy. I did the opposite. Now conversion from miles to kilometer and feet. So basically in this situation you have one input but you have 2 outputs. So the last situation, the example 5. Then create a 2 by 2, it is 4 panel figure. Inputs are 4 numerical vectors. So here you have to provide 4 vectors. Suppose var1, var2, var3, var4. So these are the inputs of this function. Then what is the output? Output will be a 4 panel figure whose each panel will create a histogram for each of the variables. So here, like for this example, you had the same data, but you had 4 different types of plots. But for this example, you have 4 different data and you will have 4 different histogram. So this is the this will be in the panel 1 will be histogram for the first variable, this one will be histogram for the second variable, this one, the third panel, will be histogram for the third variable, and this one will be histogram for the fourth variable. Okay, so follow these examples, follow the above examples and try these. Okay, then, so go through this video, and if you have any difficulty repeat that, and still if you have any problem, if you don't understand something, and if you have questions, just let me know. Okay, then, see you.